Welcome everyone. I'm excited to kick off this document preparation masterclass. Today, we'll explore how to prepare and format each technical office document correctly. Over the next few slides, we'll cover key techniques and best practices to help you produce clear, professional, and effective documents. Let's get started. Let's walk through the Material Approval Request process, or MAR for short. First, you start with the project details, making sure everything is clearly outlined. Then, you move on to the specific section of the project specification that relates to the material you're requesting approval for. Next, identify the material itself, its type, specifications, and purpose. It's important to specify the manufacturer of the material, as this helps ensure quality and traceability. You'll also need to attach the datasheet, which provides detailed technical information. Think of it as the material's technical passport. Along with that, include the compliance matrix to verify that the material meets all relevant standards and requirements. The next step is to get formal approval from the consultant. This process ensures that all technical and compliance aspects are reviewed and authorized. When submitting your MAR, make sure to attach all relevant documents, such as the datasheet in PDF format, the compliance table, the catalog page, and any test reports. These documents support your request and provide the necessary technical evidence. Finally, ensure that the documentation is formatted properly, using Word or Excel files with your company's header and revision block. This keeps everything professional, organized, and easy to track throughout the approval process. In this slide, I want to walk you through a practical example using a manufacturer datasheet, specifically for a chilled water pump. Here, we're looking at a KSB ETANORM 8160 model. The datasheet provides us with key parameters like flow rate, head, and power. For instance, it shows a flow of 65 cubic meters per hour, a head of 22 meters, and a power consumption of 5.5 kilowatts. Now, to verify whether this equipment meets our specifications, we use a compliance matrix formula. The formula is quite straightforward. It checks if the specified value matches the data value from the datasheet. If they are the same, it returns OK. If not, it suggests we need to check the data. This process is essential because it helps us quickly identify whether the equipment aligns with our project requirements, ensuring consistency and avoiding surprises during installation or operation. Overall, this example demonstrates how we can systematically compare datasheet data with our specifications to maintain quality control throughout the project. Let's take a closer look at the method statement layout and headings. First, we have the main headings, which serve as the framework for organizing our procedures. These include scope, references, responsibilities, materials and tools, execution procedure, inspection and testing, and safety PPE. Each of these sections plays a vital role in ensuring clarity and thoroughness. For example, the scope defines what the project or task covers, helping everyone understand the boundaries. References include project-specific standards like NFPA 13 for fire protection systems or ASHRAE 90.1 for energy efficiency, ensuring we adhere to relevant codes. Responsibilities clarify who is accountable for each part of the process, promoting accountability. Materials and tools specify what we need to carry out the work effectively. The execution procedure walks us through the step-by-step process, making sure we're all on the same page. Inspection and testing outline how we'll verify that work meets quality and safety standards, and safety PPE reminds us of the importance of protective equipment to keep everyone safe. Connecting this to the overall theme, a well-structured method statement ensures that tasks are performed safely, efficiently, and in compliance with all relevant standards, ultimately contributing to the project's success. Let's dive into risk assessment and PPE integration. First, it's crucial to identify risks accurately. We do this by considering three key factors: hazard, likelihood, and severity. Think of it as a simple formula. The risk index equals likelihood multiplied by severity, both rated on a scale from 1 to 5. This helps us quantify the risk level in a straightforward way. On the slide, you'll see a table that ties this all together. It includes columns for activity, hazard, risk, PPE, and mitigation. This table is a practical tool. By filling it out, we can clearly see what hazards exist during specific activities, how risky they are, and what PPE and mitigation strategies we should implement. The main takeaway here is that this structured approach ensures we don't overlook potential dangers and that we incorporate the right protective measures proactively. Integrating risk assessment with PPE is key to creating a safer work environment and aligning with our overall safety goals. Let's take a closer look at how we handle quantity takeoffs, or QTO, in Excel. One of the key tools we use are formulas. For example, to calculate the total quantity for a specific item, we might use a simple formula like equals length times QTY. This way, we can quickly get the total amount needed based on the length and the quantity per unit. Another useful formula is equals SUMIFs, QTY item, pipe. This allows us to sum up quantities for specific items, like pipes, making our calculations more targeted and efficient. Now, moving on to unit conversions, which are crucial for accuracy. If we're working with measurements in millimeters, we convert to meters by dividing by 1,000, so divided by 1,000 equals meters. Similarly, if we're dealing with weights in kilograms and need to convert to tons, we divide by 1,000. These conversions ensure our quantities are consistent and compatible with the rest of our project data. But remember, even with all these calculations, it's essential to cross-check everything against the shop drawings and legends. This step helps us verify that our quantities and measurements align with the actual construction details, reducing errors. So, in summary, mastering Excel formulas and unit conversions, combined with diligent cross-checking, forms the backbone of accurate and reliable QTO, which is vital for successful project planning and execution. Now let's take a look at BOQ and cost estimation. The key formula here is quite straightforward. Total cost equals the quantity multiplied by the unit rate plus overheads, which we typically estimate at around 10%. This helps us get a comprehensive view of the total project cost. It's important to note that we link the Excel QTO, or quantity takeoff, directly to the BOQ summary. This connection ensures that our quantities are accurate and consistently updated across the board. When reviewing the BOQ, I recommend highlighting the columns for materials, labor, and overheads. These are the main cost drivers, and keeping a close eye on them allows us to manage our budget effectively. Overall, understanding this formula and how we connect the data helps us make smarter, more informed decisions throughout the project. It's a vital part of keeping everything on track financially. Let's take a closer look at the shop drawing title block elements. Here, you'll see that there are several key fields that are essential for properly identifying and managing your drawings. First, we have the drawing number, which uniquely identifies each drawing and helps keep everything organized. Next is the scale, which indicates the proportion between the drawing and the actual size of the object, crucial for accurate interpretation. The date field is important for tracking when the drawing was created or updated. Then we have the drawn by, checked by, and approved by fields. These ensure accountability and quality control, showing who prepared the drawing, who reviewed it, and who gave the final approval. Lastly, the revision number field is vital for version control. You'll notice the revision control formula, which states that rev equals previous plus 1. This means that each time you update the drawing, you increment the revision number by 1, helping everyone keep track of the latest changes seamlessly. All of these elements together form a comprehensive system that supports clear communication, accuracy, and effective project management throughout the construction process. Now, let's walk through the as-built markup procedure, which is a critical part of our project documentation process. First, we start by collecting redline markups directly from the site. These markups typically highlight any changes or discrepancies observed during construction. Once we have these, the next step is to revise our AutoCAD or Revit models accordingly, ensuring they accurately reflect the as-built conditions. After making the necessary updates, we print out the revised drawings as a PDF, creating a clear, shareable record. Following that, we seek approval from the consultant, making sure all changes are verified and accepted before moving forward. Once approved, we archive the final version for future reference. An important aspect of this process is maintaining a revision history table within the DWG file. This table helps us track all updates over time, ensuring transparency and ease of access for anyone reviewing the drawings later on. Overall, this procedure ensures that our project documentation remains precise, up-to-date, and aligned with the actual built conditions, which is essential for project success and future maintenance. Now, let's take a look at document control and the quality checklist, which are essential for keeping our project organized and on track. First, maintaining a document register in Excel is key. This register should include columns like document number, title, revision, status, and date. These details help us quickly identify the latest versions and track progress. Next, the quality checklist covers important aspects such as format, revision, signature, attachments, and nomming conventions. Each of these elements is marked with a check, indicating whether they've been completed or verified. To streamline this process, we can use Excel's conditional formatting feature. For example, we can set a formula like equals if status equals approved, green, red, so that approved documents automatically turn green, making it easy to identify approved or pending items at a glance. Overall, these controls and checklists are vital for ensuring consistency, quality, and traceability throughout the project lifecycle. They help us maintain high standards and foster clear communication across teams.